Okay, we look at a graph and these five exponential functions. Got our basic exponential function, our toolkit exponential function, y equals 2 to the x, and went ahead and constructed this inside of a rectangle, kind of a 4x4 square as usual, and not giving any explanation of that. That's something everybody's done many times by now. Okay, now do the same thing with a 4x9 rectangle. Why 4x9? Because 3 raised to the second power is 9. So I know that I'm going to have a point here. Now, I can divide, well, I can come down here to about a third of this. So there's 1, 2, 3. Didn't come down quite low enough, but there it is, okay? And then I can come down to a third of a height. Of course, we saw this in class last time. And then a third of that height. I didn't do none of these. And we need a third of that. It's got to be real close to the x-axis. We've got a point down here. We've got a point here on the second line, a point here in the third line, and a point here and a point here. So this function has a graph that looks a whole lot like this one. That's because I compressed the 9 here. If I'd have done 9 on the same scale I did 4 on here, it'd have to be about this high. So this graph would actually go way up to about here. Anyhow, that's what the graph looks like. Your key points might be y-intercept, which is 0, 1, which is the same y-intercept you have here. Another key point on this one would be 1, 2. And the key point here would be 1, 3. Because of course, 3 to the 1 equals 3. So this would be your line y equals 3. Here's your line y equals 1. And then we have our lines y equals 1/3 and y equals 1/9. But of course, 3 to the negative 1 is 1 over 3. 3 to the negative 2 is 1 over 3 squared. So there's construction. Whichever way you want to do it, it's going to look like this. Okay. So what about 2 to the negative x? Well, 2 to the negative x replaces x by negative x, so it just flips this graph about the y-axis. That's a basic linear basic transformation. So to the negative x is going to look like this. And we can do that inside the same square if we wish. And there's a reflection. Well, make a note that to get this one, we just reflect 2 to the x about the y-axis. Of course, we can always do the arithmetic. What's 2 to the negative 2? It's 1 over 2 squared, which is 1/4. So when x is 2, y would be 1/4. And I can label these lines just for reference. This line is y equals 2. Here's y equals 1. Here's y equals 1/2. That's going to be hard to read, but I think you know what I'm labeling. And y equals 1/4 way down here. Okay. And then 3 to the negative x, well, it's also going to reflect a graph. It's going to reflect the 3 to the x graph about the y-axis, which is going to give you points here, 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 and way down here. It's going to look like this. And now, what about y equals 1/2 to the x? We could evaluate 1/2 to the x for different values, like maybe -2, -1, 0, 1, and 2. But we can also note that this is just 2 to the negative x. Because 2 to the negative x is 1 over 2 to the x. And 1/2 to the x, let's make that more explicit. You kind of look a little bit uncertain about it. Okay. This is, that's 1 to the x over 2 to the x. 1 to any power is 1 over 2 to the x, which equals 2 to the negative x. I don't even really need to draw this graph. I've got it up here. What are the important things about the graphs of exponential functions and what we see? Okay, now, can you sketch me a graph of y equals 2 to the x minus 1? Okay, so it's got a good answer to the question. How do we graph this? We shift the 2 to the x graph 1 unit to the right, which means now we can do a 4 by 4 square with y equals 4 here. And then the obvious values here, 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 and here. I didn't line that off there actually, and you get the idea. So now we're going to have a point here, 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 and here. So there's a reasonable graph, could be better. When I do this, it's helpful just to make sure we're oriented toward where the graph is. Put our x equals -1 here and our x equals 3 here. So we've kind of mark the boundaries of this region. Okay. Try this one. Well, okay, this is a horizontal 50 plus 8, a vertical 50 plus 12. Now, there are a couple of ways we can do this. One way is, okay, let's just go ahead and start with our coordinate axes. And of course, you got to come out to x equals 8 and all the way up to y equals 12. And that's where our vertex or our red dot is going to be. Question is, how big do we make our rectangle? Or 2 by 2 or 4 by 4 square? Well, if this is 8 units, 4 units is half that, so the square ought to be this wide. And of course, it gets split in the middle. And actually, we can subdivide the 8 and the x. So here would be the line x equals 2. And equal distance on the other side of the y-axis would be x equals -2. Now this is y equals 12. We want to find where y equals 4, so we can do our basic exponential function, or toolkit exponential function. So we have to subdivide the 12 into 3 parts. I still made it a little too high, but it'll work. So here is y equals 4. And we can then subdivide this and then mark our points. Their graph might look like this. Now, if we take the red dot here and move it to here, every point has to move over 12 units. So x equals -2. Sorry, it has to move over 8 units. X equals -2 will become x equals 6. X equals +2 will become x equals 10. And then we've got to move everything up 12 units so that this rectangle, which is 4 units high, will go up to y equals 16. And then we subdivide things as usual. And our graph looks like this. Alternatively, if we want to make a bigger graph, we just don't bother with the x and the y-axis because we're pretty far from the x and y-axis here. We can make a bigger graph by just saying, okay, well, we're going to put x equals 10 here and x equals 6 here. And x equals 8 here. And then we're going to go ahead and just put y equals 12 here and y equals 16 up here. That makes sense? I mean, you did that for homework a couple of weeks ago, over 2 weeks ago. You did that sort of thing. So hopefully that's helping to make a lot of sense out of these graphs. Okay, so we do the subdivision. And we plot our point. There they are. Now, I've said this before, but now it becomes really important. To extend the exponential function, every time we move 1 unit to the right on the 2 to the x function, okay, we double the value of y. So we would do that with this function. So if we move one more unit to the right, this function would double in value. So it's this high, it would go up to about this high. And we move another unit to the right, it's going to go up twice that high. So the function is going to go up very rapidly. Right? Now, this function is doubling its value from the y-axis every time we move over one. I'm sorry, from the x-axis, right? The y value doubles every time we move over one. What's that going to do over here? It's going to double the distance from the y equals 12 line because the x-axis becomes a y equals 12 line. Does that make sense? So if we're going to do what we did here, if we want to move over one unit, x equals 11, our distance from this line is going to have to double. That's going to give us a point up here. And if we go another, over to x equals 12, this is going to double. It's going to go way up here. And we won't even bother graphing that. We'll just say, okay, this thing just keeps getting steeper. Now, what happens if we go to the left? If we go one unit to the left on this graph, we go twice as close to the x-axis, right? Every unit we go to the left, we go twice as close to the x-axis. So that means every time we go one unit to the left here, we get twice as close to the y equals 12 line. Let's self-oriented by putting a red dot here. Now, the way we can say that is when we move one unit to the right, we go twice as far from the horizontal line through the red dot. Okay, that might be a lot of words, might not need to even think about that. But now, if we come over to x equals 5, and then to x equals 4, okay, we've got to go twice as close to the horizontal line here. We're really pretty close. We're only about a quarter of an inch from the horizontal line. So we're going to be like an eighth of an inch there and a 16th of an inch here. Well, the big point is we keep getting twice as close to this line as we move to the left. Every unit we move to the left, we get twice as close. Are we ever going to reach the line? If we have one unit right, implies that we double the distance from the horizontal line through the red dot. Because that's what happens to this to this graph. When we move one unit to the right, we double the y value, and the y value in this case is the distance from the red dot. Okay. Now, one unit to the left means we're going to go half the distance horizontal line through the red dot. That horizontal line's an asymptote. Okay. Now the implication of this turns out to be that y approaches infinity on this side rapidly. So we can see both of those characteristics. The line appears to merge with the x-axis, but that's only the appearance because we can't draw an infinitely thin line. And the horizontal line is infinitely thin. The official horizontal line is infinitely thin, even though we can't draw that. And the curve for the graph is infinitely thin, and they never merge. They look like they merge when we graph it, but they don't merge. They look like they merge if you graph it on your calculator, but they don't merge. Okay, well, that's the graph of y equals 2 to the x minus 8 plus 12. Now, I'm asked you to if you can do with this one. It's going to be a 3 to the x graph, and I think you can identify the transformations. If you can't, let me know, but everybody identified them correctly with the 2 to the x function. So I think you'll identify them correctly here. Okay, so how are we going to do this? Well, let me go ahead and I'm gonna do the big graph and we'll see where it is. Okay. First of all, where's our red dot going to be? Vertical shift is going to be negative 15. The horizontal shift will be negative 10. And it's the y equals 3 to the x. Vertically shifted 15 units down, horizontally shifted 10 units to the left. So the red dot would be negative 10, negative 15. Then, as we did here, the 3 to the x function would be constructed in a 4 by 9 rectangle. Got to be 4 by 9. Okay. Because 3 to the second power is 9. So this point has to be on. Okay, so this is at y equals negative 15. And this is a line x equals 10. So if we're going to construct this in a 4 by 9 rectangle with the red dot in the middle of the lower side. This is going to have to be x equals 12. And this is going to have to be x equals 8. Because now it's 4 units from here to here. And then we need 9 units in order to construct 3 to the x graph, because in the 4x4 rectangle with the red dot at the center, this thing goes up to I'll write it out. We're going to do negative 15, but then we're going to have to go up 9 units to get this rectangle. And that's going to be negative 6. Now we can construct this function. We cut the height of this rectangle. So what we have here actually, I should say 9 by 4. Rectangle for 3 to the x. Because of the way this had to be constructed. Okay. It's 3 to the x. So instead of going twice as close to the asymptote, because we see that this is going to be our asymptote now. Horizontal line through the red dot is our horizontal asymptote. From the y equals negative 6 line, we go 3 times as close to the y equals negative 15 line. So if this is 9, this distance is 3, and this would be negative 15 plus 3, or negative 12. 3 units above the asymptote. Just like this graph, this line is 3 units above the x-axis. And then we go 3 times that close. And we get y equals negative 15 plus 1, which equals negative 14. Things are getting a little bunched up here. And then I'll just draw these next 2 construction lines in here. I can't even draw the segments, maybe too close to the axis. But we sketch our points. And we sketch the curve. Based on this scale, let's just review what this is telling us. Can we estimate y when x equals 11.5? So go ahead and digest that and see if you can make an estimate. Oh, my bad here. I carelessly labeled this line x equals 10. It'd be x equals negative 10, shouldn't it? If we go 2 units to the right, we get x equals negative 8. And over here, we get x equals negative 12. So I need to change my number here. The point I was going to look at to get a fairly good estimate of. for x equals negative 9.5. What you want to do is you want to construct this graph on your paper, okay? The way I've done it. And then see what you got. Okay, so make the estimate. You have to locate the line x equals negative 9.5. Now, here's negative 10, here's negative 8. Then this line would be x equals negative 9. And x equals negative 9.5 would be between negative 9 and 10, about halfway. So here's the line. X equals negative 9.5. And then I would draw a horizontal line here. Okay, why is negative 15 here? It's negative 12 here. So from here up to here is 3 units. I would say this is about 2/3 of the way from negative 15 to negative 12, which would be about y equals maybe negative 13. And there would be an estimate. Now, not every estimate was the same, but we're just learning to draw these things and think about them. So that wasn't bad. Now, can you take your calculator and evaluate this for x equals negative 9.5? You don't have a way of calculating it without using your calculator. So this is an appropriate use of that calculator. Okay, so just in case, I think we were recording when I did that, but we located the line x equals negative 9.5. Halfway between negative 10 and negative 8 is negative 9. So the line halfway between these two lines is x equals negative 9. Then halfway between negative 10 and negative 9 is negative 9.5. And there it is. It intersects the graph here. We estimated this to be y equals negative 13. And it's not hard to get a fairly close estimate here where the curve isn't changing all that much. Turns out that the accurate and the actual y is going to be y equals, but we're going to replace x by negative 9.5. It's 3 to the negative 9.5 plus 10 minus 15. And that's approximately 13.27. And it's negative 13.27. And that's pretty accurate. Okay, so the estimate came out pretty close this time. Estimates made by people who are doing the graphs weren't quite as close, but the procedure was followed quite well. So a little practice and we can get good at this. And the main point of this is to make you familiar with these graphs. Okay.